So in this video, we will try to solve a problem where we are going to use the KNN algorithm, K nearest neighbor algorithm. So we will use this algorithm to solve a chemical engineering problem. So what's the problem? So in the table below, I gave some value of length and the width of 6 different crystals that we collected from a crystal population. Yeah? So this length and width, so they are nothing but some morphological parameters. So this is something that you can measure in the lab. So you can go to the lab or take the sample out, put it under the microscope, and you can get this parameter. So length and width. So we have two variables. So variables are typically some quantity that you can measure. So these are nothing but some measurable quantities. So this data corresponds to a particular compound called curcumin. It's an active pharmaceutical ingredient. And just assume we collected 6 crystals from a industrial crystallizer. Typically, industrial crystallizers will contain more than 1 million crystals or even more. But for the moment, let's say we collected only 6 of them. And then we put it under the microscope and we got 2 measurable quantities, which is length and width. And then what we need to do is we need to use the KNN algorithm, and we have to show that there are at least 2 categories of crystals in the population. So here the population strength is 6. So I put the sample number just for convenience. So you have 6 samples, 1, 2, 3, 4, 5, and 6. And then their properties, which we measured in the lab. So length and width. And then the type of crystal. So one is needle shape. And other category, second category, is more or less like a spherical particle. So even if you look at the data, it's something clear. So if you see the first 3 data points, 1, 2, and 3, you can see their length is much larger than the width. And then for the last 3, sample number 4, 5, and 6, length is almost equal to width. So this is something that you can expect for a spherical particle. Their length and width will be almost identical, whereas for the needle-shaped crystals, your length will be typically much larger than their width. So that's the data that you have. So you have to implement the KNN algorithm and prove how many categories we have in the data set. So before we solve the problem, I'm going to quickly revise about the KNN algorithm, or I will just tell how the KNN algorithm works. So as I said in the lectures, KNN algorithm is very simple, extremely simple, and typically we are going to perform 3 mathematical operations again and again. So I will tell what we are going to do until we meet some conditions. So it's an iterative procedure. So we repeat a few mathematical steps again and again until we meet some conditions. I will tell what are those conditions soon. So that's the KNN algorithm. So how it works actually. So let's take the same problem. Let's assume we have some information about the crystals collected from the industrial crystallizer, and we have their morphological properties, which we obtained using some good quality microscope. So we plot length and width, and let's say there are 2 types of crystals or 2 categories in the data. So green one, let's say these are type 1 crystal, or we can call category 1. And then another one is type 2, which is in red color. So these are type 2 crystals, or category 2. So when this round, this means, so these are data points. So KNN algorithm is a data driven algorithm. Yeah? So to use or to implement KNN algorithm, obviously you need some data. So these circles with the one which you see in this plot, they are nothing but some data point. So imagine you have a length and width. So if you put length as x and width as y, so x comma y become a data point. So when you plot them, you get some graph, something similar to this. For the moment, let us believe that we know there are two clusters in this graph in the plot of length and width, and we know one cluster belongs to category 2, another cluster belongs to category 1. Yeah. So just imagine if you went to lab and you have the morphological feature of a new crystal. Let this be the sample number 7. So let's, or some new crystal, and then we measured the length and the width. And if you want to know which category this particular crystal belongs to, then what we do is we have the length and width. So you plot that. Let's say if you plot, it will be, if you plot this length and width of the new crystal, let's say it's somewhere around here in this graph. And then let's run the KNN algorithm. So if you run the KNN algorithm, what it will do is it will calculate the distance between that particular data point and 5 nearest neighbors, which is somewhere around here. So I'm going to ask the algorithm to calculate the distance between this point and then the distance and the data point, any 5 data points that exist on this graph. So you have distance between this point and this point, distance between this point and this point, distance between this point and this point, and we'll also calculate the distance between the new data point and some point that exists in the category 1 cluster, and then another point that exists in the category 1 cluster. So it will calculate the distance between these data points, and then it will check what's the distance between this new data point from the data point in the cluster 1, and then the distance between the new data point and the distance between the data points in the cluster 2 or category 2. So, and then it will set the rule. So if the distance between the new data point and the data point or data points in the cluster 1 is smaller than the distance between the new data point and the data point in the cluster 2, then it will assume that this new data point belongs to category 1, So what's the rule is, so it will check for the nearest neighbor, and if it thinks it possesses the property of category 1, which is, or if it is, if the property is closer to category 1, then it assumes that new data point belongs to category 1. And if the same new data point, if it thinks, or if the calculated distance between the new data point and any of the data point in the cluster 2, if this is smaller, say like, so distance between new data point and the data points in the cluster 2, if it's smaller than the distance between the new point and the data points in cluster 1, then it will call the new data point belongs to cluster 2. Yeah, so it will check for the properties of the nearest neighbors. So if it thinks the nearest neighbor looks like category 1, then it will call, okay, this new data point belongs to category 1. If it thinks the nearest neighbors resembles the property of category 2, then this new data point will be called as category 2. So that's how the KNN algorithm works. So that's actual algorithm, but how the mathematics of KNN algorithm will looks like. So for that you have to know something called Euclidean distance. So that's something I will explain later, but for the moment I will show how the this algorithm works. So before I showed that we have length and width, and then you have two categories or two clusters. So one cluster belongs to category 1, another cluster belongs to category 2. So first, how do you make this cluster? So this itself is a huge task, and obviously KNN algorithm can classify their data into clusters so that each cluster will belong to a particular category. So for that, what we need to do is, obviously you need a very good quality data. So let's say you have length on the x-axis, you have width on the y-axis, and then let's say somehow we have some good number of data points. It looks like this on this plot. It's a two-dimensional plot. So how the nearest neighbor algorithm works? So for KNN to work, we should know some information, which is the value of k. K is equal to 2. So k depends on the number of categories that exist in the data set. If you have 2 categories, so this is some must information. So if you don't know this information, then it's very difficult to deal with KNN algorithm. So if you think your data set contains 2 different categories, then your k value will become 2. So if you know the k value is 2, then the algorithm will pick 2 random points. So 2 random points, one let's say here and another one somewhere here. So it will pick 2 random points. So one is in green, another one is red. And then what it will do, it will calculate something called Euclidean distance. I will tell how to obtain this value. So it will calculate the Euclidean distance between this green data point and then all the other data points in the two-dimensional graph. Yep. Something like that. And then again it will calculate the distance between this data point and all the data points that you see on this graph, and likewise it will also calculate the distance between the red point and all the data points in the graph. Yeah. So it's a lot of calculations, but the calculation is very simple. All it's doing is it's taking the data point and then it's calculating the distance between these data points, and then it will apply the rule. So the rule is, so depending on so which data point is closer to the green one. So let's check this one. So if it thinks these data points are closer to green point, see, something like that, and then The other data points, they are closer to the red points. So that's how, so this is something it decides based on the distance between the two data points, which is the red data point and then the green data point, and then it will assign the category to each data point based on the Euclidean distance between the randomly selected 2 points and all the points in the data set. So that's how it works. So once this job is done, so it will classify some of these points belong to the green, some of this point belongs to the red. So green means category 1, red means category 2 for the moment. So that's the rule. And then once you identified, so let's get some. So then it separates, so now we have some idea about the two different categories that exist in this graph. So that is category 1, and the remaining data points belongs to category 2. And what's the next step is, so we have length again, we have width again, and then now, so based on that cluster center, we assign some data points that belongs to each of those categories. So something like that. And then the next step, mathematically, what we can do, so we can take the average of all the x and then all the y that belongs to category 1, and then we can take the average of all the x and all the y that belongs to category 2. So it's just x1 plus x2 plus x3 plus xn divided by n, and then y1 plus y2 plus y3 yn divided by n. So that gives x comma y of category 1, and then you repeat the same calculation or the same procedure for category 2. So you will get 2x comma y. So this is the average of all the x's in the data points that belongs to category 1, and then you also get the x and y, which is the average of all the x and all the y in the data point that belongs to category 2. So what this will do, so this x and y this is something the average of all the data points. So your cluster center will move almost, so you will get a new cluster center somewhere around here, and then another cluster center which is somewhere around here. So that's how it works. And then you have to repeat this procedure. You have to repeat this procedure. Let's say so if you go back to this graph, so since this is your new cluster center for category 1, and then this point is the new cluster center for category 2. So now you recalculate the Euclidean distance between this particular point and then all the data points in the graph. So likewise, you also calculate the Euclidean distance between the new cluster center and all the data points that you see on this two-dimensional graph. And then again you apply the procedure. So based on the distance between the the new data point and the data point in that exists in all the categories. Now you assign the categories again. So now, since you have a new cluster center here, so that belongs to category 1, and another cluster center here that belongs to category 2. So based on this new cluster center, you assign all the data points around the cluster center as data points that belongs to category 2. Likewise, based on the newly calculated cluster center and the distance between the distance between this cluster center and all the data points in this graph, then you can also assign other data point belongs to category 1 maybe. So category 1, and now you have category 1 and category 2, and now you have to repeat the same procedure. So you have to take all the x and all the y and take the average. So that should automatically identify the cluster center here. And then the same, you take all the x and y and then calculate the average. So that should automatically place your cluster center, automatically identify the point that should belong to the new cluster center. So you have to repeat this procedure until there is no change in the value of the cluster center. So your cluster center, even if you keep on repeating this calculation, the new cluster center, say this one belongs to cluster 1 or category 2, and then say you have another x1, y1, which is this point. This belongs to category 1. So you have to repeat the calculations again and again until you meet the condition that there is no change in the cluster center. So that's the rule. If you manage to achieve that condition, then we can call the program is set to be converged. So then you can stop performing the iterative calculations. So the algorithm is extremely simple. You pick some random points, so k number of random points, and then it calculates the Euclidean distance between that particular random point and all the data points in the database. And then based on the distance, it classifies the data point into different categories. So if it belongs to, if the data point is closer to category 1, then it will call that particular data point belongs to category 1. And let's say this particular x, this belongs to the cluster center of category 2. And if the data point is closer to this center, then it will assume this data point belongs to your sample that should belongs to category 2. So that's how it works. So all it do is it picks some random points and then it calculates the Euclidean distance and then it assigns some categories. And once it assigns some categories, you take all the x and y, calculate the average, and then it calculates the new cluster center. And based on the new cluster center, it again calculates the Euclidean distance. And once it and based on the new Euclidean distance, it assigns each data point a particular category. And then again it recalculates the cluster center by taking the average of all the x and y in each category, and then it keep on repeating the calculations until it meets the conditions that there is no change in the value of the cluster center. So x1 or x and y that belongs to category 1, and then x and y that belongs to category 2. So this should be same over several iterations, then we stop the calculations. So let's go back to the problem. K-NN algorithm is slightly confusing, but if you think, you will realize that it's only 3 steps. So just pick a cluster center, calculate the Euclidean distance, take average, and then assign the categories, and then recalculate the cluster center, and then again assign the categories, and then recalculate the cluster center until you meet the condition which I said. So let's go and solve the problem. So problem is, you have type of crystal, which is 3 needles, 3 spherulites. So we have to show there exist 2 categories in the given data set. And then I have 2 properties, length and width. So even if you plot this data, if you plot length and width of this data, you will see some points here and some points here. So this should belongs to needle, the other 3 data points should belongs to spherical particles. So obviously this simple graph shows that there exist 2 categories. Nevertheless, our intention is to show that K-NN algorithm can identify the existence of such categories in the data set. So that's why we are going to implement K-NN algorithm and prove that there exist 2 categories in the data. So how to do that? The step 1, if you remember the procedure, we have to select some cluster center. We can select in something randomly. So if you go back to the data here, 287, and so what I'm going to do is I'm going to select 2 random points. As our k value is 2, as I said, we have 2 different type of categories. So I will select 2 random points here, 273 and 43. So that's the one I'm going to select. That's 1 point. That makes 1 point. So this is length comma width, that makes 1 data point. And then I'm going to select 87 comma 80. So length and width, that makes the second data point. So and then what we need to do, we need to, so let's say select any 2 cluster centers. You need 2 cluster centers. One is C1, 273 comma 43. So that makes a data point x comma y. And another cluster center which is 87 comma 80. So that makes another data point x comma y. So now we need to calculate the something called distance. To be specific, it's called Euclidean distance. Euclidean distance between the cluster center C1 and C2. So you have 2 cluster centers, and then distance between C1 and C2 and each of the data point in the xy space. So x comma y, this is L comma W. For convenience, I'm going to call L as x and W as y. So how to get this Euclidean distance? This is something you should know already. So just say if you have xy plane, if you have a point, let's call x comma y. Let's call x1 comma y1. So this is point 1. And let's say there is another point 2, and the corresponding coordinates will be x2, y2. So if you draw a line, this will be x2, so this will be y2, and this will be x1, that will be y1. So all we need to calculate is the distance between these 2 points. Yeah, so D, how to get that value? So for that you need to use Pythagoras theorem. So let's say so d squared. So this is the distance that we need to calculate. So d squared, that will be equal to, let's say this is d2, this distance, and this distance let's call d1. So that will be equal to d1 square plus d2 square. So d1 is difference in the x direction, so that should be equal to x2 minus x1. d2 is the difference in the y direction, that should be equal to y2 minus y1. So d square will be equal to x2 minus x1 the whole square plus y2 minus y1 the whole square, and d will be equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So that's the rule to get the Euclidean distance. So since we know the formula now, so let's go back to our problem. So let's, as I said, we have to calculate the Euclidean distance between the cluster center C1 and C2 and each of the data point in the given data set. So let's calculate it. So I'm going to call data point. Let's make a small table. This is only for our convenience. And then the distance between this data point from the and the cluster center C1. Yeah, so maybe let's call distance from C1 and distance from C2. So this column is the distance between each of the data point and cluster center 1, and the third column is the distance between the cluster center 2 and each of the data point in the xy plane. So the data point is here 287, 41, 294, 42, 273, 43, 78, 74, 81, 74, 87, 80. So that makes 6 crystals. So sample number 1, 2, 3, 4, 5, and then 6. So you have 6 samples. So let's calculate the distance using the formula which I showed you now, this one. And we know cluster center C1, I will write it here. C1 is 273, 43, and cluster center C2 is 87, 80. So how to calculate the distance? It's very simple. Take the square root of 287 minus 273 the whole square plus 43 minus 41 the whole square. And here is the same, 287 minus 87 the whole square plus 80 minus 41 the whole square. So 287, that's the actual data point, 287 and 43, and 273 and 41 are the cluster centers, cluster center 1. And here is the same, 287 is the actual data point, 287, 80, and 87 and 41. So this is the data point that belongs to the cluster center 2, so which is here. Likewise, you have to repeat the calculation, and for all the 6 sample, for data point in 6, it will be equal to distance between the data point 6 and the cluster center 1. That should be equal to 87 minus 273 the whole square plus 80 minus 41 the whole square. And similarly, the distance between the data point 6 and then the cluster center C2, that will be equal to 87 minus 87 the whole square plus 80 minus 41 the whole square. No, that will be 80 minus 80 the whole square. So if you make if your calculations are correct, then you will get something like this. So let's make the graph data point, and then so distance between each data point and cluster center C1, and then distance between each data point and cluster center 2, which is C2. So data point is 287, 41, 294, 42, 273, 43, 78, 74, 81, 74, 87, 80. So this distance will be 13.52, 21.53, 0, 192.47. This is something you have to check. 182.08, and here it will be 203.1, 210.52, 189.53, 10.66, 8.98, and then 0. And then now check the distance between each data point and the cluster centers, which is C1 and C2. So I'm going to call the distance between each data point and each data point, say this one, and then the cluster center C1 as D1, and then each data point, and then the distance between each data point and cluster center C2 as D2. So this one will be D1, other one will be D2. So in this case, D1 is smaller than D2, D1 is smaller than D2, D1 is smaller than D2. Yeah, for all these three. And for the last three, we see D1 is larger than D2, D1 is larger than D2, D1 is larger than D2. So what it means is, so all these three data points, they are closer to cluster center C1. So I'm going to call the first three data point belongs to category 1. So all three belongs to category 1. And then the last three data points, if you see that D2 is smaller than D1, so which means each of this data point, they are much closer to the cluster center C2. So I'm going to assign these data points belongs to category 2. So now we apply the second rule of KNN. Since we know three of the data points belong to category 1, and another remaining 3 belongs to category 2. So now you take the average of all the x, y of the data points in category 1 and average of x, y of all the data points in the category 2. So that should give the new cluster center. So recalculate the cluster centers. So that's the next step. Recalculate the cluster centers based on the newly assigned categories. So we assigned first 3 data points. So these 3 data points, just follow the pen. This belongs to category 1, and then the remaining data points belong to category 2. So we have 287, 41, 294, 42, 273, 43. They all belong to category 1. And then we have 78, 74, 81, 74, 87, 80. They all belongs to category 2. So now take the average of all the x and all the y. So 287 plus 294 plus 273 by 3. So that makes the average of x, comma, 41 plus 42 plus 43 by 3. So that gives the average of y in category 1. And similarly, you get the average of all the x and y of all the data points that belongs to category 2. So that will be 78 plus 81 plus 87 by 3, comma, 74 plus 74 plus 80 by 3. So this should give the new data point that will be approximately equal to 284.64, comma, 75.95. No, that's not correct. So this should be equal to 284.64, comma, 41.89. So that makes the new cluster center C1, and then for C2 this will be equal to 81.92, comma, 75.95. So that something belongs to cluster center 2. So now what we need to do, we have to calculate the Euclidean distance. So next step, calculate the Euclidean distance between the cluster centers C1 and C2 and the data points, all the data points, and then again assign the category based on the distance that you calculated. So this is something I'm not going to do because so even if we try to make a new calculation, so let's say data point. So we know that the first, let's write it, 294, 42, 273, 43, 78, 74, 81, 74, 87, 80, and then the new cluster center C1 is given by 284.64, 41.89, and then the cluster center 2 is we calculated just now 81.92, 75.95. So we need to calculate the Euclidean distance between each of these data point and the cluster center 1 and then the cluster center 2, and then again you have to assign the category based on the Euclidean distance. So even if you do the calculation, you will see that D1 will be less than D2, D1 will be less than D2, D1 will be less than D2 for the first 3 points, and then again here D1 will be greater than D2, D1 will be greater than D2, D1 will be greater than D2. So what we got, and if we recalculate, and so based on this we can assign the categories again, something like first 3 data points belongs to category 1, and then the other data point belongs to other 3 data points belongs to category 2. And if we take the average again this will give C1 that will be equal to 284.64, 41.89, and again it will give C2 will be equal to 81.92, 75.95. So what it means is like the last iteration and the previous iteration gives the same cluster center, so which means the program is converged. So which means for the given data set you have obviously 2 categories, one is C1 and C2, category 1 and category 2, and their cluster centers given by this value. C1 is 284.64, 41.89, and then the cluster center is 81.92, 75.95. And if you plot the actual given data set, you will see something like that. So this cluster center will be in the middle of all the 3 points, and this cluster center will be in the middle of all the 3 data points that belongs to category 2. So that's the solution for this problem. So just to revise, all you need is to pick k number of random points. So in this case, we assigned a cluster center. So randomly, we selected 2 cluster centers. And then we calculated the Euclidean distance d1, d2. So d1 is the distance between the cluster center 1 and all the data points in the given data set. d2 is the distance between the cluster center 2 and all the data points in the given data set. And then based on the d1 and d2, if d1 is smaller than d2, then we assign that data point belongs to d1. If d2 is smaller than d1, then we assign that particular data point belongs to category 2. And once you know which data point belongs to category 1, so let's say you have 3 data points, and then another category, it contains 3 data points. We take the average of all the x and y. You get the new cluster center, and you take the x and y of all the data points in category 2, and then you get the new cluster center. And again, you recalculate the Euclidean distance between the new cluster center and all the data points, and the second cluster center C2 and all the data points. And then again, you assign the category and recalculate the cluster center. So you repeat this procedure until you get the same cluster center twice. So your nth iteration and n minus 1th iteration should have the same cluster center. So then the program is said to be converged. So nth and 1 minus nth iteration. So both should have the same cluster center C1, C2. So that's all for today.